Friends. After defining permutation, let us define what is a combination. Every selection which can be made by taking some or all of a given number of things without considering their order is called a combination. Notation: if there are n different things and we want a group or a selection of R things, then the number of combination is denoted by NCR or CNR. The formula for NCR is n factorial divided by R factorial into n minus R factorial. To understand the meaning here, every combination of R things give rise to R factorial permutation, because combination of R things have no order. If we permute them, they give rise to R factorial permutation. Thus, NCR combination gives rise to R factorial into NCR permutation. Therefore, R factorial into NCR is equal to total number of permutation, that is equal to NPR. Or in other words, NCR is equal to 1 by R factorial into NPR, which gives equal to n factorial divided by R factorial into n minus R factorial. It must be noted that NPR is equal to R factorial into NCR. From the above definition, we can find out that NCR is equal to NCn minus R. It is because they are called complementary combinations. That is, NCn minus R is equal to n factorial divided by n minus R factorial into n minus R factorial. Using the above definition, we get n factorial divided by n minus R factorial into R factorial. That is equal to NCR. This justifies the number of ways in which we can make a selection of R students of a class of n students is the same as the number of ways in which we can reject a group of n minus R students from that class. That is why they are called complementary combinations. Second, NC0 is equal to 1, that is equal to NC1, and NC1 is equal to NCn minus 1, which is equal to n. NC0 is given by n factorial divided by 0 factorial into n minus 0 factorial, which is equal to 1, and NC1 is equal to n factorial divided by 1 factorial into n minus 1 factorial, which can be written as n into n minus 1 factorial divided by n minus 1 factorial. That cancels, give rise to only n. Therefore, NC1 is equal to NCn minus 1 is equal to n. Another result follows that NCA equal to NCB implies either A is equal to B or A plus B is equal to n. Clearly, if A is equal to B, NCA is equal to NCB. But if A is not equal to B, then NCA is equal to NCn minus A using the previous result. Therefore, NCn minus A is equal to NCB. That gives n minus A is equal to B or A plus B is equal to n. Another important result is that NCR plus NCR minus 1 is equal to n plus 1 CR. Consider the left hand side. NCR plus NCR minus 1 is equal to n factorial upon R factorial into n minus R factorial, that is the value of NCR, plus n factorial divided by R minus 1 factorial into n minus R plus 1 factorial, which gives us n factorial divided by r factorial can be replaced by r into r minus 1 factorial into n minus r factorial plus n factorial divided by r minus 1 factorial into n minus r plus 1 factorial can be replaced by n minus r plus 1 into n minus r factorial. Taking LCM, we get r into r minus 1 factorial into n minus r plus 1 into n minus r factorial, and in the numerator we get n factorial into n minus r plus 1 plus n factorial into r. Pulling out n factorial common in the numerator, we get n factorial times n minus r plus 1 plus r divided by r into r minus 1 factorial can be replaced by r factorial, and n minus r plus 1 into n minus r factorial can be replaced by n minus r plus 1 factorial. The numerator becomes n factorial times n plus 1, and in the denominator we get r factorial into n minus r plus 1 factorial. But the numerator can be replaced by n plus 1 factorial, which is equal to n plus 1 CR. That is the value we have on the right hand side. That proves the result.